Welcome to an insightful journey into the world of petroleum geology, which is the starting point of oil and gas resources, presented by Serdar Kaya from Grenergy LLC, USA. In this presentation, we will explore a variety of topics including the petroleum system, oil occurrence, and the fascinating journey of hydrocarbons from rocks to reservoirs. We will also elaborate reservoir properties, exploration steps including seismic and drilling. Petroleum geology is a scientific discipline focused on the origin, occurrence, movement, accumulation, and exploration of hydrocarbons like oil and natural gas beneath the Earth's surface. A petroleum system is a dynamic hydrocarbon system operating within a specific geologic space and time. It consists of naturally occurring organic compounds primarily made of hydrogen, carbon, and oxygen, as well as migration and storage of hydrocarbon fluid. Petroleum originates from organic matter, mainly microscopic marine organisms, buried in sedimentary basins millions of years ago. Source rocks like shale undergo thermal maturation, transforming organic matter into hydrocarbons under extensive pressure and temperature. Essential geological events for hydrocarbon deposits include maturation of source rocks over time, migration, retention, and expulsion of hydrocarbons in geologic traps. Hydrocarbons in each reservoir come in various forms with unique features and distinct properties such as API range, gas-oil ratio, viscosity, and color. Category of hydrocarbon ranges from bitumen to dry gas. Tar sands, a type of unconventional petroleum deposit, can be found in places like Atoka County, Oklahoma, and Alberta, Canada, showcasing the diversity of hydrocarbon sources. The generation, migration, and accumulation of hydrocarbons are crucial processes in petroleum geology, determining the availability and accessibility of these resources. Organic matter in sedimentary rocks, such as vitrinite, plays a vital role in petroleum source rocks, with its reflectivity indicating the maturity of coal rank and thermal maturity. Total organic carbon, TOC, is a key indicator of hydrocarbon generation potential, with varying levels in shales and carbonates indicating different stages of oil window maturity. The mechanism of petroleum generation and destruction involves stages like diagenesis, catagenesis, and metagenesis, transforming organic debris into oil and gas through thermal degradation and cracking. Comparing maturity techniques helps us understand the limits of oil and gas generation, with factors like vitrinite reflectance and pyrolysis playing crucial roles in this analysis. Key elements for hydrocarbon accumulation include the source rock, reservoir rock, seal rock in the form of a trap, and timing, all of which must align perfectly to form a viable petroleum system. Petroleum systems consist of various elements such as impermeable rocks, which is called also cap rock, reservoirs, and source rocks, each playing a critical role in the formation and trapping of hydrocarbons. Exploration techniques in petroleum geology include geological mapping, seismic surveys, well logging, reservoir rock coring, and geochemical modeling, all essential for identifying potential hydrocarbon accumulations. A cross-section of a petroleum system reveals how the essential elements like source rocks, reservoirs, and seals interact for hydrocarbon deposition, forming a commercial oil and gas reservoir. Historical migration pathways, such as those during the Campanian time, illustrate the vertical movement of hydrocarbons from source rock through geological formations, offering insights into past reservoir dynamics in UAE. Structural and stratigraphic traps are geological formations that capture hydrocarbons, with their unique shapes and layers playing a pivotal role in oil and gas accumulation. In petroleum systems, source rocks generate hydrocarbons, reservoir rocks store them, seals prevent their escape, and overburden rocks contribute to thermal maturation. Geological and geophysical analysis of this system is highly important in a successful early exploration activities. Hydrocarbon traps can be classified into structural traps, formed by the deformation of rock layers such as anticlines and fault traps, stratigraphic traps, created by depositional changes like pinch-outs and reefs, and combination traps, which are a mix of both geological mechanisms. These illustrations depict various types of hydrocarbon traps, showcasing the complexity and diversity of geological formations that can hold oil and gas. Understanding these formations is key to successful exploration and extraction. Structural hydrocarbon traps are formed by geological structures such as folds and faults. Examples include fracture basement traps, fold traps in the form of anticline, and salt dome forming virus trap. These structures create three-way or four-way closures that can trap oil and gas, making them significant targets in petroleum exploration. Stratigraphic hydrocarbon traps are formed by changes in rock deposition. Unconformities, pinch-outs, and channel pinch-outs are typical examples. These traps rely on variations in rock layers to create spaces where oil and gas can accumulate. Dome-shaped hydrocarbon traps are characterized by their distinct geological structure. The dome shape allows for the accumulation of oil and gas beneath layers of sandstone and shale, creating a natural reservoir. Fault traps occur when rock layers are displaced by faults, creating spaces where oil and gas can be trapped. These traps are often found in areas with significant geological activity and are important in the search for hydrocarbons. Beyond structural and stratigraphic traps, there are other types such as asphalt traps and hydrodynamic traps. These traps involve unique geological and chemical processes that can lead to the accumulation of oil and gas. Combination traps integrate features of both structural and stratigraphic traps, while salt dome traps are associated with the movement of salt through rock layers. Both types offer unique opportunities for oil and gas exploration. This illustration shows a combined structural and stratigraphic trap, highlighting the potential for oil and gas accumulation in complex geological settings. Such traps require detailed analysis to understand their full potential. Cross-cutting relationships are essential in geology for understanding the relative ages of rock formations. They help geologists decipher the history of geological events and the formation of hydrocarbons.